Hey guys, Mr. Palmer back with the last part of this galvanic cell review. The last part of this equation asks us about doing calculations. That is, if we're looking at the moles of electrons that are being transferred in a galvanic cell. You can also use this kind of setup in an electrolytic cell too. In this case, it tells us that we have a current of 685 milliamps being transferred in this cell, and it's running for a time period of 75 minutes. So a couple things about this. You're given a current, right? Current is equal to the charge over time, which means that current times time is going to give us the charge, and that's really what we're looking for. We want the amount of charge, the amount of electrons that are being transferred in this reaction, and that's going to allow us to figure out the amount of product that's going to be created. Current is measured in amps, and so 1 amp is equal to 1 coulomb per second, right? That's 1 amp. 1 amp is 1 coulomb per second. That's an important idea to keep in mind here. So if we come up to our calculation, we've got 75 minutes. We're going to have to put that in seconds. We've got 685 milliamps. We're going to have to put that in amps. So let's start with the first part, number 1. How many moles of electrons are transferred? I would start with the amount of time. So we have 75 minutes. Let's do a little dimensional analysis to see if we can figure out how many moles of electrons are transferred. So we're going to start by taking that number of minutes, and we're going to turn into seconds. So 60 seconds in a minute. Let's take a look at our current. What's the relationship of current, or that is charge, to time? That's what the current's going to tell us. There's 685 milliamps. So that would be 0.685 amps, or 0.685 coulombs per second. Right? Because remember, amp, coulomb per second. So that gives us the coulombs of charge. We need one more piece of information to get our moles of electrons, and that's Faraday's constant, which is the fact that there is 96,480, or on your equation sheet it'll say 96,500 coulombs of charge for every 1 mole of electrons. If you do the math, that's going to come out to be 0.0319 moles of electrons. The second part asks us to actually find the mass of copper that's going to be plated. Remember, copper is at the cathode. That is where you have the metal being plated out. The anode is getting eaten away. The aluminum ions are being dissolved into, the aluminum metal is being dissolved into aluminum ions. So at the cathode, this copper is going to be plated out. We know how many moles of electrons have been transferred. So to turn that into a mass for part 2, what you need to do is take that quantity, the 0.319 moles, and use this relationship. Remember, this is moles of electrons. For every 2 moles of electrons, you will get 1 mole of copper. Why is that? Well, our copper is going from Cu2 plus 2 electrons to Cu. It takes 2 moles of electrons to convert 1 mole of copper ions into copper atoms. So then the last step is just to say, okay, every 1 mole of copper is going to be 63.55. We're just going to use its atomic mass, grams. Okay, so we took the moles of electrons first, times the relationship, the number of moles of electrons per 1 mole of copper, multiplying by the atomic mass. That gives us 1.01 grams of copper that are going to be plated out. So the cathode is going to generally increase in mass throughout this galvanic cell running, and the anode is going to decrease in mass. Again, you can put any questions you have in the comments. I'll try and get back to you as soon as I possibly can. Thanks for watching, guys.